So hey guys, welcome back again. Today we're going to solve the Leet-code problem number 876. That is our middle of the linked list. Okay. So basically, we are given a linked list, and we have to find the middle of the linked list. Okay. So let's took an example one. When our nodes are odd. So basically, it's 1, 2, 3, 4, 5. So our middle will be 3. So this is our middle. And basically, and when example number 2, so when our nodes are even, basically 1, 2, 3, 4, we'll consider 3 as our middle, not this. So what will be the for nodes are odd? So as per the question, so for this when nodes are odd, so our input is like just a 1, 2, 3, 4, 5, and our output will be 3, 4, 5. And for this case, for this event, so this also input will be 1, 2, 3, 4, and then our output will be 3 and 4. Okay. So basically, how we can solve this problem? So we're going to solve this problem by using two pointer concept. One is first pointer and one is our slow pointer. So we have to move this first pointer and slow pointer, and we have to find a relationship between our first pointer and our slow pointer. We have to find the we have to find the relationship between first pointer and slow pointer. Okay. So basically what we have said, what we have said in the question we have said that we have to find the middle of this element, basically half. We have to break this linked list into half, and what will be the middle of the element? From that element to the from half to end, we have to return those nodes as our output. Okay. So basically, so how we are moving our first pointer and second pointer? So our first pointer will move 2x speed and our slow pointer will move 1x speed. Okay. So consider this element. So when our slow pointer is here, our first pointer will be our first pointer will be here. This is the first case. And second case, when our slow pointer moves 1x time, so we're moving our slow pointer 1x time when here, so our first pointer will be here. And in the third case, when our slow pointer is here, our first pointer will be here. So basically, as our first pointer is moving 2x time, then slow pointer 1x time. So when our slow pointer is when our first pointer reach at the end of the node, so our slow pointer will be here. So we'll basically simply this return this slow pointer. So after this, we will traverse all the nodes. So basically, that will be our answer. So basically, how this so basically this is our answer. So how we can approach this? So in our code, or what will be our algorithm? So first algorithm, we have to take two pointers. Take two pointers. One is first pointer that points to head of our head. That is the first one that will point to our linked list. And take another slow pointer that also point to our head. This is our slow pointer. Now now we will increase our fast pointer and increase, so we will increase fast pointer and slow pointer until what, until our fast next until our fast next not equals to null pointer. Okay, so basically when our fast next, so when our when our fast pointer reach at this end, and after that there is no nodes because this is our singularity, so we reach the null pointer. And when the fast pointer reach the null pointer, our slow pointer will come here, so this is our slow pointer. That's it. So basically the pseudocode for this, while fast is not equals to null pointer and fast next not equals to null pointer, oh, sorry, while fast next not equals to null pointer, we basically what will increase, we will increase the fast as so we will increase our head as fast next. Here we are increasing two times or 2x time our pointer. So basically basically we are updating here was our fast, then fast next, and then fast next mean we are moving our pointer, updating our fast pointer as here. And we will basically, and as our slow pointer is moving 1x time, so we'll basically do the slow and then we'll do the slow next. That's it. That's happen iterate on this. So this is iterating until the null pointer. So when this fast pointer uh, so when fast pointer reach at this end, our slow pointer will be basically here, and will simply our return slow pointer. That's it. So that's the code, and you can solve this problem using this concept. Hope this helps you. So that is the basics approach, and this is not optimized method, or maybe this could be optimized, I don't know. And if you know the optimized solution, please comment in this video. So hope see you soon in this later video. Thank you. Bye bye.